For the first question, our group need to design a 1 to 8 demultiplexer. So the diagram show 1 to 8 demultiplexer block diagram, which it has 1 input and 8 outputs with 3 selection lines. So to design a combinational logic circuit, we need a truth table. So for 1 to 8 demarcs, here is the truth table, where the outputs are depending on the selection line binary value. So for example, we can see here, if the selection line are set to 101, binary are 5, so the input will be rotated to the output y5, and the other y output will become zeros. So after we obtain the truth table, we can get the Boolean expression for all output, and then from the Boolean expression we can design a circuit, a combinational circuit. So here is for the simulation part, we use EDA. So on the right part is for the design module. So we need to declare the input D in, input S2, S1, S0, and output from Y0 to Y7. And then after that, we are going to use the assign for each output. So the assign we use are data flow type, where the Boolean expression are used. The Boolean expression that we got are used to write back in the coding, in the Verilog coding. All Boolean expression that we obtain will be written in the design module. Next, for the test bench, we need to declare the module back with tb_main, and then the input become register, and for the output we use wire from y0 to y7, and then we have the main UUT for the test bench. So then we need to write all the possible values for the test case. Okay, so in this part here, we need to use the timestamp. So from the D in, S2, S1, and S0 value, all are we write it in the coding. So all the possible value were from 000 till 111. So all cases will be written here. And then for the waveform part, okay, we need this part, dump file and dump files for to get the waveform part. So after we have both of this coding, we can run, and we should get the EP waveform pop-ups. Okay, let me show the results. Okay, at time first. So you should got this back. So this result should be the same with the truth table. So you can see here, when 000, only y0 is 1 and other output is 0. Same goes to the next one. When it's 001, only y1 is 1 and the other output is 0. And this should be repeated until 111, and only y7 is 1 and other output is 0, return to 0. And then here is the waveform generates. Okay, we can see also it's the same result, where when at S0 1, then only y1 is 1. So when S1 is 1, at y1 it become 1 and other output is 0. This continues to S3 110 until 111, and the y7 become 1. So this proof the simulation results are the same with the concept of 1 to 8 demarcs, truth table, and all the input output results.
This video will show the simulation for the question 2 assignment. First, declare the input and output for the test bench. Then, instantiate the device under test.. Write the value to monitor same as the input at the waveform at the question 2. This is the line code to generate the waveform for input and output, and the module for test bench. Next, for the design Verilog code, declare the module name first. Then declare the input and output. After that, write the Boolean equation based on the circuit design. Finally, we can run the simulation. We can see at time 30s, the input is 100, producing the output 1. We can see also the output at the bottom of test bench code.